All right. Lab 8 linked list. For this lab, we'll complete our implementation of the singly linked list and a doubly linked list. We did not start the doubly linked list, so I will go over that briefly, but the code is going to look remarkably the same. Or similar, sorry, not the same, similar. Ooh, that was close. So singly... No. Hey, look, we already wrote the constructor in class. This one, we're going to pass it a singly linked list that you've already constructed, and then you got to make a copy of it, a deep copy, which means you recreate all the nodes inside of the new singly linked list. Everyone understand deep versus shallow? Great. Make sure it deconstructs, get the length like I talked to. Append appends it to the end of the linked list. Insert val at position pose. All right, so this is where linked list gets a little tricky. So this is where it's going to be a little extra work. But how could we implement this insert function?
We can have an if statement for the one we already had, where m head is equal to null. So you're having to insert the first element.
Right. Let me write an example of this function because I see it's a little confusing. Insert, we'll call it 2. Oh, that was crazy. 9001. Position 2. That's position 0, position 1. So then we'd want to go into position 2. It's 9001. And then that would point down here, and of course we get rid of that arrow. You see what I mean by position 2 now? All right, so you're gonna have to make a while loop or some loop that goes down 2 positions. By the way, if the position is out of bounds, you need to return false, because I will definitely be testing for that. So, that makes sense what insert is? Perfect. It's not too bad because if you write it correctly, you don't even need to have a previous pointer. Print, I am not testing the print function. This is here for your own convenience. I highly suggest you use it. Hey look, removes, similar to exactly what we did. Normally I do not make students write this function, but I think since we just learned arrays, or we've been using arrays, we should do it for a linked list. The subscript, which kind of doesn't make any sense on a linked list, I put it in there anyways. You're just getting the element of that at that position. So in other words, subscript, let's go 1 is going to equal 20 because position 0, position 1 has a value 20. All right. We'll do position 3. Was that 0, 1, 2, 3? That'd be 13. By the way, with this subscript, if it goes out of bounds, your code, that's okay. Your code's just going to fail. That's what it's supposed to do. Only on this operation. I know it's a little confusing. That's why I don't like operator overloading. But in this situation, if I put in a -1 or 9,000 and you don't have the number of elements, just let it give a fault. Let me make sure that's what I told you to do. Yes, perfect. And then just returns if the 2 list contains the same elements in the same order. So they have to be both in the same order, the same elements. Notice that also means it has the same number of elements. So if the 2 lists are logically equivalent. All right. How's everyone doing? All right, so we're going to go to doubly. The doubly linked list is the exact same interface. I highly recommend you copy and paste it over because we're really only going to do a couple of things with the doubly linked list. I think it's fairly straightforward, but it can cause some issues. So I'm going to convert this picture up here to a doubly linked list. Everyone ready for this? Hey look, there's an arrow going both ways. Whoa. Make that arrow go right here. Make this point back. And then, what should the arrow over here point to?
In head.
Now, M head's pointing to the first element. And the first element back is what? Null. Because you got null on one end, you got null on the other end. All right? Okay?
Whoa, man, that's amazing.
Wow. What this actually does, that's somewhat helpful, is it simplifies deleting, because now you don't need to have a previous pointer, because you can go backwards now. The problem now is you have to make sure you maintain both the front and the back pointer. So when you get to this point, you're going to have to sit down, copy it over, and then I highly recommend you draw some pictures about where the arrows need to go forward and backwards for the test cases that we went through. So I think we did three cases where you're deleting the last one and the first one, and then deleting one in the middle. I would recommend doing it in that order. It's just going to make your lives a little easier. Again, copy paste the code, and then just replace it. And of course, hopefully you still have your test cases from your singly linked list. If not, you'll be writing them. You'll be writing some probably for this one, because the auto grader definitely knows how to get some gotchas in this one. All right. There's going to be some corner cases here, guys. That's just how it is. Any questions? Okay. This lab is a little on the heavy side. I just want to know what the performance difference for append. We talked about this, an array linked list. That was the big O. I just need big O of 1 versus O of n. That's all you need to say. You know, array is O of n, the worst case. Same thing with insert. Hopefully you can see that insert is always going to take a certain amount of time in array as well as a linked list, and as well as the other, as operator, removing and searching. All right, and then it is due a week from today. That is a week from, yeah, that's good, week from the day. And if I recall correctly, lab, is it
4 and 6 are tonight.
due tonight? Is lab 5, was that due?
That was last week.
Okay, so I haven't gotten to lab 5, so I'll grade lab 5 soon. Thank you. Yeah.
Our lab 7 is this Wednesday.
Excellent. Good, and we'll finally get back on the standard track. Perfect. Any
So when's lab 6 due then?
Tonight.
tonight? Lab 4 and 6 are due tonight.
I'm gonna need help with that one.
Okay,
'Cause I didn't know that it was due today, so just.
that's good. Well, that's fine, yeah, because I'm finishing 5 minutes early. Any other questions? Comments? Don't forget to think about project 1. I've introduced a linked list. You're free to use a linked list as well as an array to help you with project 1. But we'll get to a couple other things with project 1, but you need to be thinking about it. All right, anything else? All right, that's all for today. Have a good day. I will